Okay, so today we're going to discuss how we can work with non-right triangles. As we see triangle ABC, we have a 26-degree angle, a 42-degree angle, and an unknown angle. Using the fact that all the angles in the triangle add to 180, we can figure out this is actually 112 degrees. All right, so clearly not a right triangle. But we're going to use some strategies just like when we found area of shapes, particularly composite shapes, of breaking them into different shapes so we know how to find the area of. We're going to try and break this into two right triangles so that we can use all the stuff that we know about right triangles that we spent the past couple of weeks working on, like Pythagorean theorem, sine, cosine, tangent. The last couple of days you've been doing the special right triangles. So any of that stuff might come into play. And we're going to see how that works out to help us find this missing side length x, given this angle is 26, this angle is 42, and this is a side length of 4 centimeters. All right, so I'm going to split this triangle like this. And we notice that, and I'm going to force this to be 90 degrees. Because this is a straight line, using our angle relationships, these are supplementary angles, so that is also 90 degrees. All right, so I'm going to call this point D, just so I can name these triangles. So we have two right triangles. Triangle ADB is a right triangle with a 90-degree angle being here, and triangle CDB is a right triangle. Again, the 90-degree angle is right there. All right, so we're not going to separate them, but we could. But we have two right triangles. Next thing I notice is there's a shared side between these two right triangles. BD is in both of these right triangles. So if I find that length, that can help me with finding the length of x. All right, so I'm going to call that length that we don't know h, just because it happens to be the height of that triangle. All right, so I'm going to start by trying to find the length of h, given that angle C is 42 degrees and side length BC is 4 centimeters. All right, so if I'm labeling this right triangle with opposite adjacent hypotenuse, DC is the adjacent side length with respect to 42, H is the opposite side length with respect to 42, and 4 centimeters is the hypotenuse. All right, so that tells me I'm trying to find the opposite length. I'm given the hypotenuse, so I must be using sine. So the sine of 42 equals h over 4. If I want to solve that for h, I can multiply by 4. 4 times the sine of 42 equals h. Type that in our calculator. Make sure you're in make sure you're in degree mode, so you get the correct answer, and you get 2.68 roughly is the height of that triangle. So I'm going to fill that back in over here, 2.68. All right, now if I look at triangle ADB, that right triangle, I have an angle. I now have a side length based on the work I did over here, and I'm trying to find another side length. So that allows me to use sine, cosine, or tangent once again. So in the triangle ADB, I'm going to label adjacent, opposite, and hypotenuse once again to figure out which of these I need to use. So with respect to 26, this is my adjacent side length. This is still opposite, so I'm going to leave that label right there. And here is the hypotenuse. So the difference is I'm not finding the opposite side, I'm finding the hypotenuse, but I'm still using those two side lengths. So I'm again using a sine ratio. So the sine of 26 equals the opposite, which is 2.68, over hypotenuse, which we're trying to find is the length of x. All right? Just like above, to get rid of that fraction, we're going to multiply by x to cancel that on the bottom. X times sine of 26 equals 2.68. Now to solve this for x, because it's not by itself, we have to undo multiplying by sine of 26. So we divide by sine of 26. And we get x equals 2.68 over sine of 26. If we type that in our calculator, once again, we get about 6.1. All right, so that side length right here is 6.1 centimeters. Now, there's quite a few steps involved with that process. The first one is it's going to be hard to identify where to split your triangle to make this into two right triangles, because it's going to change based on the type of triangle that you're given. So in math, we've actually come up and generalized a process that allows us to work with non-right triangles, provided this similar type of information. That's going to be a little bit more efficient for us. So the next thing I'm going to do is I'm going to run through what that looks like, so we can avoid this, to come up with an easier way to find out how to find that same information. So I'm going to redraw that same triangle down here, but I'm going to generalize it, so I'm not going to put any side lengths in it. So I'm still going to call this angle A, call this angle B, call this angle C. Now, instead of labeling these with certain degree angles, I'm just going to leave them blank for the time being to come up with a general equation. All right. Next thing is, instead of calling this side length BC, I'm just going to call it side length lowercase a, because it is across from angle A. All right, so angle A creates this side, so I'm calling that side length A. Angle B creates this side length, so I'm going to call that angle B, side length lowercase b. And then angle C here creates this side length, so I'm going to call this lowercase c as the length of that side. All right, so I just have this triangle here. I want to figure out what these angles and sides have in common. So I'm going to go through the same stuff that I did above by splitting this into right triangles and using sine, and I'll see what happens. All right, so again, if I split this into right triangles, we have this. Again, this is point D. So the first thing I did was I looked at how to find this height of the triangle, so I'll call that H. And I used this angle, trying to find this, and we provided this length here above. So if we do something similar, we have sine of angle C equals the height over side length A. Before we had side length A, but now we're generalizing it, so we're just going to call it length A. Then once I found that, remember I solved for H, and then I had the height. Then I tried to find this length here using this angle and the height that I found. So if I set up that sine equation, I have sine of angle A equals the height of this triangle. And now I was trying to find this length, which in this case is represented by C. One thing I noticed is that both of these have the letter H involved. We said that was the common side that was shared above. So what I'm going to do is I'm actually going to solve both of these for H. So I'll multiply this by A, multiply this by C on both sides to undo that. And that leads to A times sine of angle C equals H, and C times sine of angle A equals H. All right, now this here is a system of equations. We have two equations. Think back to Algebra 1. We talked about in Chapter 4 systems of equations, mainly the three strategies that we have for solving those. Of course, those were equations of lines. These are different equations, but it's still a system of equations. The three strategies we have are equal values, substitution, and elimination. Because both of these are equal to the same letter, this sets up nicely for equal values. So if this equals H and this equals H, then these two must equal each other because this is the same H. All right. So essentially this gives us A times sine of angle C is equal to C times sine of angle A. I don't know about the rest of you, but it kind of bothers me that I have a C and an A on this side and a C and an A on this side, rather than all the A's together and all the C's together. So that's kind of our last step, is getting the C's together on one side of the equation and the A's, because we're talking about the side length and the angle it creates. So I'm going to divide this by C to undo dividing by C, and divide this by A to undo dividing by A. And that leaves sine of angle C over side length C is equal to sine of angle A over side length A. And this is the equation that we're looking for. All right. So what this says is if you take any angle in that non-right triangle and take the sine of it and divide it by the side length it creates, that is equal to the sine of any other angle in that non-right triangle over its respective side length. So in this case, I'm comparing angle A and side length A to angle C and side length C. But that is, I could also use angle B and side length B as well. Okay, it's any angle divided by its side length. The sine of any angle divided by its side length is equal to the sine of any other angle divided by its respective side length. Okay, so we call this the law of sines. So we're going to reference it as from now on. So I'm going to go back and do this initial problem once again using law of sines rather than splitting it into the right triangles to show that we still get 6.1 as that missing side length. All right. So I'm going to redraw the triangle exactly the same as above. All right, so I have that triangle drawn. Again, I'm not drawing the right triangles any longer. I'm going to use law of sines. So if I have A, B, and C, this is side length A, this is side length C. Obviously, this is angle C, this is angle A. So applying this, I'm going to fill in the values that I know. I know angle C, I know angle A, and I know side length A, and I'm trying to find side length C. Okay, so it looks like this. Sine of 42 over, I don't know that length, so I'm going to use x still. That's equal to the sine of angle A, which is 26, over its side length 4. Now we notice there's only one thing missing in this equation, that's the length x, and we can solve an equation for a single variable. Okay, this is a proportion. We've been solving these for a while, going back to probably like 8th grade or so. Most of you use the method called cross multiplication. So you multiply these two, and you multiply these two, leaving 4 times the sine of 42 equals x times the sine of 26. So if we're solving that for x, we want to get x by itself. We're going to divide by sine of 26. Undo it on that side. And we have 4 times sine of 42 over sine of 26 equals x. Awesome. If we go back and type this in our calculator, making sure, again, we're in degree mode, making sure we pay close attention to the parentheses here and we're dividing everything correctly, we do get that this equals 6.1. All right, so it is the same answer as we got above. It's a little bit more efficient because all we're using is the information we're provided, plugging that in, cross multiplying to solve that proportion. Okay, so law of sines has two applications. The first one is we're trying to find a side length. That's this example right here. The second application is we're trying to find an angle. So maybe we're given two of these side lengths, but only one of these two angles. We can still use law of sines to find that missing angle in that non-right triangle. Okay, so that's the last example I'm going to go through, just so you've seen every way that you could possibly apply law of sines. All right, so what I'm going to do is I'm actually going to remove the 26. I'm going to keep the 42 degrees, keep the 4 centimeters, and we know we've done this twice now that x is 6.1, so I'm going to fill that side length in, and we're going to go through and show that law of sines will give us that this is 26 degrees. All right. Ooh. Okay. So we don't know this is 26 yet. We're trying to find out. I'm going to call that theta for now. This is 42 degrees, 4 centimeters, 6.1 centimeters. Angle A, angle B, angle C. So again, I'm going to start by labeling this is side length C, this is side length A. You can label this side length B, but we're not using it, so it doesn't matter. All right, again, law of sine states the sine of angle A over A equals the sine of angle C over C. So again, I'm going to fill in what I know. I know this is angle C. We're trying to find angle A. This is side length C. This is side length A. So I have sine of theta over 4. That is equal to sine of 42 over 6.1. Again, proportions, we solve those with cross multiplication. That leaves 4 times sine of 42 equals 6.1 times sine of theta. What I'm going to do is divide by 6.1 to get rid of it on this side. We're trying to isolate theta. So first we're going to isolate sine of theta. So if I divide this by 6.1, I'm going to type this in the calculator so I get a decimal approximation. Just give me 1 second to type this in the calculator. 4 times. We get about 0.439 approximately equals the sine of theta. And then the week before spring break, we talked about how to undo sine, cosine, tangent with their inverse functions. We had a worksheet on that. So to undo sine, we use sine inverse. Okay, so that's going to cancel sine on this side and leave us with the sine inverse of 0.439 equals theta. Okay, so I just got to type this in the calculator. And it comes out to 26.04. If we just round that accordingly, we get that 26 degrees equals theta, which is what we said that angle was initially. Okay, so we see that we can use law of sines to find a side length or an angle. There's just really one additional step in finding the angle. Here you would have what x is. We have to do undo sine, so use inverse sine to get that last step to find that angle. Okay, so main summary for today, we don't need to split non-right triangles into right triangles any longer. We kind of just use that process to come up with law of sines. So what you want to know is what law of sines is. And then we went through 2 examples of how to use it. The first one is how to find that side length given 2 angles and one of the side lengths. And the second one is how to find an angle given 2 side lengths and 1 angle. Again, the important thing you need to know for law of sines is this side length A is the one across from the angle. Okay, so go all the way across the triangle. This is side length B. This is side length C. That's what you need to know to figure in these. You should have 1 complete fraction, 1 fraction with 1 piece missing, whether it's an angle or a side length. If you have questions, please feel free to email, and we can answer those that you have.